Your assistant has come a long way. It reads your own notes, it calls tools, it chains them together, and back in episode 4 you even learn to measure when it gets things wrong. So let me put you back in that exact moment. You ask it a real question. How many days until my music streaming renews? And it answers confidently with a number that is just wrong. Now here is the part that quietly breaks people. You changed nothing, so what do? You shrug, you run it again, maybe you reword the question, and you hope. Because under that one wrong sentence, a whole chain of things happened that you never got to see. It searched your notes. It picked some text. It called a tool. It called the model. One of those steps is where it all went sideways, but which one? Right now, you genuinely cannot tell. Your agent is a black box, and today we are going to pop it open and watch every single thing it does so that when it breaks, you do not guess. You look. So let us really look at what is hiding inside that box, because the reason this is so hard is that there is no single thing in there. When you ask your agent one question, it is not one action. It is a little assembly line. First, it takes your question and searches your notes to find the relevant ones. That is retrieval. Then it reads what came back and decides what to do. That is a call to the model. Maybe it decides it needs today's date, so it calls a tool. It reads that result, calls the model again, and finally writes the answer. 4, 5, sometimes dozens of separate steps, each one feeding the next. And here is the cruel part. Every one of those steps can fail in its own way. The search could have grabbed the wrong note. The tool could have returned an error or the right answer to the wrong question. The model could have been handed a perfectly good note and just ignored it. Each of those is a completely different bug with a completely different fix. But from the outside, they all look identical. The same calm, wrong sentence at the end. You are trying to fix a machine you are not allowed to see inside. No serious engineer would ever accept that. So you do the natural thing. You try to debug it the way you debug anything. You sprinkle in some print statements, print the question, print what the search found, print what the tool said. And honestly, for a tiny toy, that sort of works. But watch it fall apart the moment things get real. Your agent does not run one step. It runs a tree of them, steps calling steps calling steps, and now your terminal is a flat wall of text with no shape to it. Worse, you cannot tell what called what, or in what order, or how long each piece took, or which model call quietly burned half your tokens. And the thing you most need to know, which step came right before it went wrong, is buried somewhere in that scroll. Printing tells you a few things happened. It does not show you the structure of what happened. And for something that branches and loops like an agent, the structure is the entire story. We need something built for exactly this shape. And it turns out, it has existed for over a decade. Because long before AI agents, software engineers had this exact problem. One request would come into a big system, bounce through 20 different services and come out wrong, and they needed to see the whole path. So they built a discipline for it, and they gave it a name you should know: observability. It is actually an old idea from engineering, the ability to figure out what is going on inside a system just from what it puts out. And the specific tool for it is called tracing. Here is the whole idea, and it is genuinely simple. You record every single step of one run as it happens. Each step becomes a little record called a span, and a span holds the things you have been desperate to see. The exact input that step received, the exact output it produced, how long it took, and for an AI step which model how many tokens and how much it cost. Now the clever part. The steps are not a flat list. They nest. The model call that triggered a tool call becomes the parent, and the tool call is its child. So all the spans from one run snap together into a tree. And that whole tree, the complete story of one question from start to finish, is called a trace. One run in, one trace out. This is not some new AI invention, by the way. It is built on an open standard called OpenTelemetry that the whole software industry already uses. We are just pointing a battle-tested idea at our agent. Now watch what that tree does for you, because this is the whole point of the episode. Go back to our wrong answer. How many days until my music streaming renews? Before, all you had was the final number. Now you open the trace and you see the entire run laid out as a tree you can walk top to bottom in order. The root is the whole run. Under it, the first child is the retrieval step. You click it open, and you can read in plain text the exact note it pulled from your search. And right there, immediately, you can see it. It did not grab the music streaming note. It grabbed your gym membership note. Both are just recurring payments, so the search confused them, the exact mix-up we caught back in episode 4. And now everything after it makes perfect sense. The next span shows the model being handed the gym note and faithfully, obediently, calculating the days for the wrong subscription. The model was not even broken. It did exactly what it was told, with bad ingredients handed to it one step earlier. You did not guess that. You did not rerun anything. You read it straight off the tree, and you found the first step where reality and the answer parted ways. That is the move. You walk the trace until you hit the first span whose output is wrong, and that span is your bug. And here is the part that should make you happy, given everything this season stands for. You do not pay a cent for this, and nothing leaves your computer. There are 2 excellent, free tools that do exactly what we just described, and you run them yourself. The first is Langfuse. Its core is open source under a permissive license, and you can run the whole thing on your own machine with a single setup. As of early 2026, it became part of the company behind ClickHouse, and it stayed open source, so the free self-hosted path is still right there. The second is Arize Phoenix. It is free to self-host as well, and you start it with basically one command and a local web page opens up. A small, honest note so you can say it precisely. Phoenix is source available rather than strictly open source, which just means the code is open and free for you to run, with one limit. You are not allowed to resell it as your own hosted service. For us, running it on our own laptop, that limit never even comes up. Both of these are built on that same OpenTelemetry standard. Both show you the trace tree, the inputs, the outputs, the tokens, the latency, and the cost, and both cost nothing. Pick either one. We will use one of them in a moment for real. So let us actually do it free on your own computer. Here is our local assistant, the same QN3 agent over my notes. To trace it, I do almost nothing. I wrap my steps so each one gets recorded, just a small decorator on each function, and I point it at my own self-hosted dashboard running right here on my machine. Nothing goes to the cloud. Now I ask the question that failed. How many days until my music streaming renews? And again, it gives me the wrong number. But this time I open the trace. Look at this. The whole run drawn as a tree. Here is the top, the full question. I expand it, and here is the retrieval step. I click in and I can read exactly what it pulled. And there it is in plain sight. It retrieved the gym note, not the music streaming note. The bug is not in the model. It is right here in the search one step in. And notice everything else the trace just handed me for free. Each step is timed so I can see what was slow. Each model call shows its tokens and its cost. I did not add any of that. It came with the tree. One question, one trace, and the invisible is now sitting right in front of me. Now 2 honest limits, because a trace is powerful, but it is not magic, and knowing its edges is what makes you good at this. First, and this is subtle, a trace shows you what happened at every step. It does not show you the model's WHY. When you saw that the model was handed the gym note, the trace told you the input and the output perfectly. But if a model is given a perfectly good note and still ignores it, the trace will faithfully show you that it ignored it, and it will not tell you the reason buried inside the model's billions of numbers. Looking inside that black box, explaining the model's actual reasoning, is a whole separate and genuinely unsolved frontier called interpretability, and it is so deep we will spend real time on it later. A trace is the security camera footage of the building. It shows you exactly who went through which door and when. It does not read their mind. And second, just as important, a trace does not tell you that something is wrong. It only shows you what happened. You still need something to declare this answer is bad and to flag which step looks off. That something is your evaluations from episode 4. So now you can see the beautiful pairing. Your evals tell you that it failed and on which questions. Your trace tells you where in the run it failed. Together, they turn debugging from a shrug into a method. And every failure a trace exposes can become a new row in that eval set, so your test keeps getting sharper. So here is the whole thing in one breath. Your agent is not one action, it is a chain of them, and when it fails, the failure is hiding in one specific link. Tracing records every link of one run as a tree of spans, each holding the exact input it got and the exact output it gave, plus its time, its tokens, and its cost. You read that tree, you walk down to the first step whose output went wrong, and that right there is your bug. No more guessing, no more rerunning and hoping. And the best part, you do all of it free, on your own machine with Langfuse or Phoenix. Debugging just came back to AI, but now sit with what you have actually built. You have an agent that searches your private notes, calls real tools that can act in the world, and a trace that records every single step it takes. That is enormously powerful, and it is also exactly the moment to get nervous. Because if your agent reads a note, or a web page, or an email that contains hidden instructions, that text flows straight into the very steps you are now watching. The same trace that lets you debug your agent can show you the agent being quietly hijacked into doing something you never asked for. So next, before we trust this thing with anything that matters, we have to learn how it gets attacked and how to defend it. That is guardrails and security, and it is where we go next.